Hi everyone, we are Group 21, and today we're presenting our project, the Local Grocery Price Tracker, a web application built to help users compare and track grocery prices across multiple stores, specifically Target, Fry's, and Amazon. The purpose of our application is to support budget-conscious shoppers by offering tools that help them make more informed purchasing decisions. So our system allows users to search for specific grocery items, filter by categories and zip code, view real-time price comparisons, track price history, manage personalized shopping lists, and even receive alert when preferred product go on sale. On technical side, our backend is powered by PostgreSQL, custom and database for managing server, and our front end is built using React to ensure a responsive and user-friendly interface, and structure our database to handle key features like coupon, price tracking, and user preference. With this project, we aim to deliver a useful tool that saves users both time and money while shopping.
Hello, I'm Theron from Group 21, and I'm going to be doing the app demo for our project. So I'm just going to go ahead and run the app locally here. As you can see, I just started the server from the backend directory, and it connected to the database successfully. Now I'm going to go ahead and run an npm start on the front end, and as you can see, the local grocery price tracker has opened. This is the home page of the site. You can see there's a bunch of different options. You could filter the products available in the database by their category. We have featured deals available. You can filter by store, or you can view all products. And as you can see at the bottom here, or in the header, you have an option to sign up and create an account, where eventually features like shopping lists will be implemented. And as you can see now, I've just completed this. I'm completing a search for apples. Shows apples, and there's also a search for bananas. And you could, once you click on an item, you can see a bunch of different information about the item. Uh, and as you can see down there, you can see similar products. So let's go to the apple, which is a similar product to the banana from Target. And yeah, so you could also filter by category. So once you apply that filter for dairy, you can only see the dairy products from the database. We could also do produce. So let's apply that filter, and you can see all the produce available. And now let's go ahead and click on the item from the featured deals. You could also filter by the store it's sold from. So once you apply that Amazon filter, you can see air chilled chicken, which is supplied from Amazon. You can also do Target, so let's apply that Target filter. And you can see products available sold by Target. And now I'm going to go ahead and show the sign up feature. As you can see, it takes you to a sign up page. So let's just make a dummy account, tester at tester.com, and put in a simple password. And then it also asks for your zip code, and you can set your monthly grocery budget. And as you can see, I am now logged in, and the items look different. They have an add to cart button for once the shopping lists are implemented, and you still have a bunch of other options. Once you have an account created, at any time you can navigate to the profile tab, where you can view your profile information and do things like updating it. So let's go ahead and click edit profile, where you can edit the fields. For example, you could edit your monthly budget that you input. So let's edit this from $3 to $20 and save that. And then after refreshing it, after refreshing your profile tab, you can see that your monthly budget has been updated and saved. And so yeah, let's just log out of our dummy account, and now we will be back to the normal local grocery price tracker homepage. So yes, thank you for watching our app demonstration for our project.
Hi, my name is Kushal Pandey, and I will be going over how the registration and login functions work for our local grocery price tracker. As you can already see, this is the front end React code for the registration page, which has error handling in it and the various functions required. and this is the app itself. Uh, I'll just make a new account. Excuse me. Just make a new account right in front of you. As you can see, right over here, I've added all of the input fields and I signed up. This ensures that I have made a new account. And to verify, I will show you the PG admin, which will be updated. So right over here, as we can see, it just added a new account at the very bottom, the one that I just made. And as for the login function, this is the front-end React code for the login function. And now I'll show you on the app itself how the login function works. So I will log in with one of the test emails that are already in the database. And there you go. The product, the homepage of the products, it basically logs in and unlocks a few features that are not available for unregistered users, like the add to list button. And as you can already see, this is the example email that I just used to enter into the app. And this is the example of real life scenario where the new users whose data will be inputted for signups will only be cross-referenced with a hashed password for increased encryption. And that is my presentation for the login and register features. Thank you so much.
And that concludes our walkthrough of the local grocery price tracker. For our implementation, we started by designing a relational database schema with 7 interconnected entities. We carefully structured our tables with appropriate primary keys and foreign key relationships to maintain data integrity while allowing efficient queries. The PostgreSQL database backend provides strong support for complex queries, especially when tracking price histories and filtering products by multiple criteria. We've implemented all necessary SQL operations, insert statements for adding users and products, update queries to modify prices, delete operations for removing outdated data, and select statements with joins to retrieve comparable pricing information. For our front-end, React components manage the UI state and handle user interactions. We separated concerns by developing distinct components for product searching, shopping list management, and price tracking. The database and front-end communicate through API endpoints that execute parameterized queries to prevent SQL injection. Data retrieval is optimized through indexing on frequently accessed columns like product names and price values. We've also implemented transaction management to ensure data consistency when updating related tables. The price history tracking feature relies on timestamp-based queries that identify trends over time, while the alert system uses database triggers to notify users when prices change. Our database schema supports scalability, allowing additional stores and product categories to be added without structural. Overall, this project demonstrates practical application of database concepts from schema design and normalization to query optimization and transaction handling, all wrapped in a user-friendly interface.